So this video will serve as an introduction to alkenes and to the reactions of alkenes. And so what is an alkene? An alkene is a compound that contains at least one double bond. Alkenes are said to be unsaturated, whereas alkanes are said to be saturated. And what that means for an alkane, which is saturated, it just means that the every carbon in the chain is linked together by a single bond, and all of the other bonds to carbon are hydrogen bonds. And so something that's unsaturated contains at least one double bond. All right, so we also are going to talk about in this video alkene stereochemistry. And what that simply means is the way that the groups are oriented around the double bond. And we'll get to that in a second. So here's some common alkenes that you may or may not have known about. Lycopene is an alkene. It's found in tomatoes. It actually helps to give tomatoes their red color. Capsanthin, which is shown here, is an alkene. Has actually several double bonds that are what we call conjugated, meaning that there's a pattern of alternating double and single bonds. And capsanthin is found in paprika as well as red peppers. DHA, which is shown here at the bottom, is a fatty acid that's been known to stimulate brain function. And so these are alkenes that are just commonly found in nature. So one of the things about alkenes that we have to learn is how to calculate what we call degrees of unsaturation. All right, degrees of unsaturation gives us an idea of the number of double bonds present in a given molecule or the number of rings present in a given molecule. So to calculate degrees of unsaturation, we need an empirical formula, which is shown here. And let's just look at this formula with some compound with the formula C10H14. There are two steps to calculating degrees of unsaturation. The first step is to calculate what I like to call the reference empirical formula, and we learned this before, CnH2n plus 2. All right, so for a compound that has 10 carbons, the reference is C10H22. Right, 10, you plug in 10 here for the number or for the variable n, so 2 times 10 plus 2 is 22. All right, that's the first step. The second step involves subtracting the number of hydrogens in the actual formula from the number of reference hydrogens and then dividing by 2. So from the previous slide, H reference is 22, and then the actual number of hydrogens is 14. So H reference minus H molecule, which I have here, divided by 2. That's how we calculate the degrees of unsaturation. So 22 minus 14 is 8. If we divide that by 2, that means that this particular compound has 4 degrees of unsaturation. What does that mean? And these are just some examples. A compound with the empirical formula C10H14. Again, if we have 4 degrees of unsaturation, that means we could have 4 rings or 4 double bonds present. So we could have 4 rings present, like this compound here. We could have 4 double bonds, like this compound here. We can have 3 rings and 1 double bond. We could have 2 rings and 2 double bonds, or we could have 1 ring and 3 double bonds, like this one. And one thing to remember is that all of these molecules have the exact same molecular formula of C10H14. So there are 2 exceptions here. Number 1, if there's a halogen present. So let's look at this empirical formula, C6H10Br2. All right, if there's a halogen present, in this case we have 2 halogens present, we subtract 1 from the reference number of hydrogens for every halogen that's present. So here, if there's 6 carbons, the reference number of hydrogens is going to be 14. So since there's 2 halogens present, we have to subtract 2 from the reference. So that's 14 minus 2, which will give us 12. The number of hydrogens that are actually in the molecule in the empirical formula shown here are 10 hydrogens. So again, if we apply the formula H ref minus H molecule divided by 2, it's very simple. 12 minus 10 divided by 2 is 1. So you only do this in the case of halogens being present. Anytime there's a halogen present, you subtract 1 from HREF for each halogen before you actually apply the formula here, HREF minus H molecule divided by 2. Okay, so the second exception is shown here with a molecule with this empirical formula C6H7NO2. All right, anytime that there is a group 5 atom present, then you add 1 to HREF for each atom, each group 5 element that's present. All right, so in this case we have a nitrogen, which is from group 5. We only have 1. So HREF for this compound would be C6. So N would be 6, so 2N plus 2 would be 14. So before we apply the HREF minus H molecule divided by 2, we first must add 1 to HREF. So this would be 14 plus 1. That would give me 15. And then 15 minus 7 divided by 2 would mean that this particular molecule with this empirical formula has 4 degrees of unsaturation. And again, that means that it could have 3 rings and 1 double bond. It could have 3 double bonds and 1 ring. It can have 4 double bonds. It just depends on. So you can actually play around with the structure and determine or propose some structures for this particular empirical formula. So again, when you only do this when there's a group 5 present. You calculate HREF, then you add 1 to it, and once you do that, then you can apply the formula here, HREF minus H molecule divided by 2.